Okay, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. It's Wednesday at 7:30 p.m., and we're here at the Adafruit factory, me, Lady Ada, and Mr. Lady Ada, and Blinka the Snake, and our payphone. And we're having a good time. We're going to hang out here for the next 20 minutes or so and have people from around the community and around the world come by and show us what they're working on, whether it be CircuitPython or 3D printing or cosplay or scanning electron microscopes. We'd love to see what you're hacking on. Doesn't even have to be Adafruit stuff. So yeah, we're going to be here till about 7:50. Take a couple minutes when we call on you. Show off your project. Keep your mic muted until then so we don't get weird echoey effects. We'll start off with some Adafruit peeps, and then we'll roll into guests from around the world.
Start with JP.
Let's start with JP. What are you crafting in your workshop?
All right. Well, I'll tell you what I'm crafting in my workshop. I am crafting something that's going to use our Bluefruit Connect app to turn on and off the lights. So the setup for this is that in my workshop, when the door is rolled down, very difficult to actually get to the main overhead light switch, and sometimes I want to turn that off when I'm filming, and so I have to grab a yardstick and kind of reach across a CNC table and whack at it. It's super not convenient. So what I've got going on is hidden under this. I'm going to show the details of it tomorrow on the show. Hidden under here, I've got our brand new NRF 52840 feather and a cricket. And if I use the Bluefruit app right now, I can light switch on and off.
I like that it kind of goes back so you can still use the switch.
Yeah, that's right. Yeah, so in software I set it up so that it kind of goes into this neutral place so that the switch is still usable by human fingers. But if you want to use your robot fingers, there you go.
You can also use your watch. Is this iWatch compatible?
Oh, that's right. You can use an iWatch. I've been using the iPad because I can't take photos or video of that while using it. So I've got to have two iOS devices to do that, just to document some stuff. So I'll be showing that and the details of that on the show tomorrow on the live stream. So come on by and check it out.
Okay, cool. All right. Thanks for the preview. And then, of course, last week you did the gauntlets. Check out that guide. All right. Next up, let's go to Noah and Pedro.
Hey, everybody. So this week, continuation with the Steven Universe props, we got Rose's shield. So fully foam core construction. Got the Circuit Playground Express in the middle with the meter-long NeoPixel strips on the inside. And the way we're connecting everything is just with alligator clips. So super simple construction. You have all the SVGs, so you guys can cut this out with a vinyl cutter, or you can just freehand cut this like I did. Just a bunch of hot glue to hold everything together. And one of the cool things is that it's fully modular, so you can actually take this whole guy apart, and I can show you what the guts look like on the inside. Ooh. Everything is all removable, so all of these components come out, so you can travel with this or reuse the components. And of course, this completes, I think, or starts to complete with last week's project, the Pearl Spear. I think we're going to work on Obsidian's Master Sword next. After all the characters fuse, it's like the next like weapon that they form. And full hour that we talked about this on 3D Hangouts, and we also have a bunch of other sneak peek stuff that we're working on. So definitely check that out.
All right, thanks for working on another Cartoon Network collab. Us, Make Code, and Cartoon Network working together to making cool cosplay props and projects.
Yep. Tune into Ask an Engineer tonight, and you'll see some of these videos from Noah and Pedro.
Yeah.
Okay.
All right, Mike. Come on by.
So this week I've got a new guide on Lucky Cat. So you might have seen these in the shop. So it's a simple guide that you make. It's cardboard. It uses a Circuit Playground Express and a servo, and he's cute. So you make it cardboard. We're echoing here.
Yes,
okay, there we go. So I have this guide. It's already up in the Adafruit Learning System, so you can check it out. And there should be a guide soon. Yep, there we go. Using Circuit Playground Express also. And it's not that I just use this all the time because I wrote a book about it. It's that.
But you did, and people should buy the book.
Well, now you're going to get Caitlin's dad all spun up. Now, this is a pulse detector. So it uses the light sensor on the Circuit Playground Express and lights up one of the NeoPixels. So you cover up the...
Can you hold it up?
Oh, there we go. You hold it up and... did it blink? It takes a couple of seconds. It needs to start averaging my
there you go.
So hopefully this is a rendition of my pulse. I wouldn't bet your life on it like a doctor, but it's kind of fun because it uses just all the parts that are already on there, so you don't need anything else. So there'll be a guide with CircuitPython and MakeCode. So pick your favorite language and you can check it out with your Circuit Playground.
I think you have to put your finger on it. I think it was going a little bonkers. I don't think your heart rate's that fast.
My heart rate is fast.
Really?
I have a really fast heart rate.
Okay, good. Well, we'll need that for when the vampires attack or something. All right, sweet. Thanks for the Lucky Cat and the preview of the heart rate sensing stuff.
So I think Scott is still setting up possibly a camera. So we'll wait. Yeah, we'll wait. Do you want to talk about your thing anyway, Scott?
Yeah, I don't have a whole lot of faith that I'm going to be able to get it going.
Yeah.
Oh, let's just hold up what you got. Maybe next week.
CircuitPython has me spoiled. You just plug it in and it works.
I know.
So you have a full Linux computer webcam that you're going to have to troubleshoot for 4 hours.
Yeah, working on it. So I'll just do the old school style. I'll hold it and show you what I've got. But basically, I talked about the terminal and CircuitPython a little bit. If I take you on a ride, and I forgot this one is also. There's my hover cam that's not working.
Okay.
That'll work.
All right, so we got Grand Central.
So Grand Central, not USB to the computer, to parallel display. And then these 4 wires are going from the Model M keyboard. And so if I don't know how well you can see it because I attached my webcam cord to my thing, but if I type, it actually works.
Yeah.
Hit return a couple times. I see that. You can definitely see it then.
And I just fixed return.
Oh, nice. All right, so you basically have a Coco CircuitPython.
Yeah, so it's a standalone CircuitPython. So I'll be at the Hardware Happy Hour in Seattle tomorrow with it. Just give people a chance to play around with it, and it's cool using the old keyboard with it as well.
No, it's good. I mean, it's you're totally ready to hack anywhere now.
Yeah, I'm wondering who the first person to write an editor for CircuitPython is, so you can like swap between editing Code.py and running Code.py.
Well, you've got an SD card there. You could just have whatever you could just type into Code.py. You can port ed or VI.
Right.
That'd be nice.
All in JMKOS probably too.
JMKOS could run on it. All sorts of good stuff.
Oh, one thing real quick, Scott, the little computer icon on the hover cam, if you press that, it's a touch screen, you may need to switch from the settings to make it USB so it shows up, by the way.
If it doesn't, it doesn't do anything. It doesn't think I'm human. Like the touch screen's not, or maybe it's down here.
There's a touch screen, but there's also buttons beneath the touch screen, and there's one that has like a camera.
It might be the protective plastic on it too. Anyways.
Camera icon.
Oh, camera. Oh, isn't that a screenshot?
No, there's the little computer. Anyways, we'll keep going.
Enjoy.
Oh yeah, you know me.
We need some quality time with that. All right, so let's go to Dave Estelle's next.
Hey, Dave.
Hey, Dave.
Hey.
Hey.
So, if any of you remember, early last year, mid last year or something, I did that humidity monitor for storage jar.
Uh-huh.
Right, and that used a trinket is written in C. And just use some tones for indications. Well, I've revisited that project. Let me switch cameras. So now we have this that should be in focus.
Yeah.
It's using a feather, which is there. It's using the 3-color e-ink display. And again, with the piezo buzzer and the TPL 5111 this time that hooks to the enable. So if we wake it up, the great thing is though the e-ink display stays there, whether or not it's on, because basically sleeps for an hour and comes up and does a measurement.
Oh, nice.
And yeah, the display is updating. And also, it's a 152 by 152 pixel display, so you can get a lot of information there. Yeah, and you can hear it beeping. Yes.
Yeah.
Maybe.
Beep beep.
Yeah, and with the red to highlight when there's a problem, and it can tell you exactly what the problem is with the temperature and the humidity. Push button to stop the annoying alarm. And where it says contents and the temperature range and humidity ranges are all parameters stored in a file on the CircuitPy drive. One file for all the settings, another file for the descriptive text of what's in the jar. So you can just hook it up with USB to charge it because it's using a feather, and also to edit those parameters and data. So it's nice and easy to use. That's it.
Sweet.
Okay.
I feel like my jars are well-minded. Nice work.
And excellent work on the CircuitPython cheat sheet, which is now part of awesome CircuitPython. Thank you, Dave.
Yeah, that was fun.
That was really good. Okay.
All right, next up, TG-Techie. Welcome back, Commander.
Thank you for having me back. So last week I came on
screen.
Last week I came on and I showed a little bit of my functional tricorder.
Yes.
And I'm coming to do a little update.
Okay.
The update is it got worse because it's getting better. I'm rewriting the GUI from scratch, and I started that 9 days ago, I think, maybe 10. But it's gotten. Is it washed out?
Oh yeah, I can see it.
No, I can see it. There's buttons.
I've gotten it to this point, back to this point, I should say. And basically, it's a much lighter implementation, but it's also far easier to implement for someone else to use, so to speak. If I screen share, are you seeing my screen?
Yeah.
Okay. This is the main, and basically anything you want to customize is in main.py. So it's passing it a rect and a text function, and then telling it, hey, I want you to use this program by default or not. And if I open up Serial, oops, let me reboot. I implemented a command line interface for moving through the GUI so that it's easier to tell it how to move through the GUI instead of setting up a separate file that has the function inside of it. You just use your Python in your main.py to talk to it as if you're talking to it over the REPL. So it says command.
Yeah, isn't it like interpreted languages are so weird?
Yeah, but it's so easy to like iterate, and
you can just do stuff, and it's like, okay, do stuff whenever. You don't have to compile it or.
Yeah.
All right, so move
so
right.
The things that the interpreted languages run are themselves compiled, in my opinion. So if I say move.right, just move.right, and I hit enter, it will, it'll freeze because I unplugged my USB back. So, okay, I'll work on having a second camera for next week.
Okay, we believe you. But come back next week and show some more demos.
And I'm still going to send you out one of our upcoming devices, so then you can rewrite everything again for that.
Hopefully, it should just be passing a rectangle and a
might just work.
Some text.
Yeah.
Oh, and this supports touchscreen because it uses a pointer for everything. So even moving through menus uses an on-screen pointer. So supporting a mouse should just be about buffering a display.
Nice.
Cool.
Done. I promise.
Sweet.
All right. Okay. Next, let's go to Michael.
Make it so. All right. Next up, Michael. Hi, Michael. We can't hear you. Yeah, that's you.
We can hear you.
You're the Michael.
So I thought I'd drop by this week, and you know, it's been a long time since I've been on the show, and a lot of things have gone on since I last came on. This week I wanted to talk about the Bacon Bits cape, which is a pocket beagle cape that I designed last year. I don't know if you guys saw that out on the web somewhere.
I did today.
Yeah, well, I may have posted it. I may have posted a lot about it, actually. because
Oh, it looks cute.
the campaign. It's a pocket beagle cape, and I remember, you guys remember I brought the original pocket bone, the design that I made on, and I was gonna have a demo, but I never did. And then that went on to be the pocket beagle. And then the pocket beagle, we designed a cape to do basic IO, and so what we intended on using it for was a course that is for device drivers and embedded Linux. It was pretty much, we wanted to cover all the subsystems, the basic subsystems, and so we wanted hands-on with some hardware. So, and we didn't want a bunch of different daughter boards and jumper wires and stuff for the class. It was a course called EALE, Embedded Linux Apprentice or something like that. And what I did is I said, okay, let's just put everything we need on there for the course. So I added, there's a USB connector, which is really nice. The Pocket Beagle doesn't bring that out, so I brought it up onto here. And then I added these, if you can see it, there's the emulated 7-segment LEDs. So what I did is I took 0603s and I oriented them like a 7-segment display. And then I drove them with this MCP 23S18, I think it was. It's a GPIO controller, or open drain maybe. And then I have a tricolor LED. This is not a NeoPixel. It's actually just a plain LED. We're driving that with just PWM. So we got 3 PWMs driven by the base SoC. And then we have accelerometer. I don't even think you could see it on there.
Yeah, your camera's not going to be able to.
Oh, got it.
Okay, got it. Like
so yeah, there's an accelerometer on there. It's way right tucked underneath the LED. And that guy is, just the tri-axis. Then I actually, because this is a course that was going to cover low-level bootloader and device drivers, sometimes you need the serial con. I actually put an FTDI chip on there so you can have the low-level debug console. And the last thing we added was this magical scrolling potentiometer dealie over here. So what it ended up doing is covering I2C, SPI, PWM, GPIO, and analog input all on one board, so that we could test the different, we can teach each of the different subsystems for the course. And then what we did is we had an instructor for each subsystem would come in and they would give a kind of a run through the subsystem. And then they give, hands-on lesson at the end. The first go at it was last year at Scale. I actually taught 2 of the classes. One was an SPI and one was on I2C. Then they went on to have another one at ELC, and the more recent one I think they had at LCA, and they had a different hardware that they used for it. But this upcoming Scale, we're going to use this hardware again for teaching the courses again. But I think they're going to change it after that to something else. So I wanted to make sure so that other people out in the community that can't afford to go to these conferences, I wanted to make the hardware available to them. So I launched a small crowdfunding campaign, and that'll be out on Group Gets.
What you should do to make it easier for people to use is we have CircuitPython drivers for a lot of stuff, and we have some BeagleBone black support. So you should look at Blinka, which is our compatibility layer for CircuitPython libraries. And that way people can take advantage of, we have drivers for like the MCP23 and the List3DH and analog input. So if you get that going, then people don't have to use low-level BeagleBone stuff. They can use CircuitPython, and that can be like really helpful.
Yeah, well, the initial course was for kind of more advanced users.
Yeah.
But I think that for like newer users, I would imagine they would use the Bone script or the encapsulation drivers that you're talking about. I worked with Drew a little bit on the I2C extension for the Blinka thing. I remember he asked me, "Hey, what do we have to do here to get this working?" That would be really cool, and it's something that we were looking forward to possibly doing as a Google Summer of Code project. Would be to add more support for the Circuit Python on the Pocket Beagle and BeagleBone
Yeah.
Block.
I think that's something that people really like. I mean, we did it for Orange Pi, and it just got. They're like, oh yay, we can actually use all these drivers now.
Post up a link in Discord with all the information so folks can check it out.
Yeah.
Okay. Yeah, I can post.
And if you want a sticker, email support@adafruit.com.
Yeah, I don't really need that. Oh, and the other thing was that KiCad conference, but I think I've kind of gone over time.
Yeah, we have two more people we got to get.
We have a post going up. We're a sponsor, so we'll get the word out on that.
Okay.
Okay.
All right,
Thanks so much, Michael.
All right. Next up,
I do want to stop at Scott's camera for 1 second because it looks like you got to work.
Scott, there's a turnaround, reversey button.
If I flip it, it flips. It's still wrong.
No, that's correct now.
That's right now.
Okay, it's wrong for me.
Yeah.
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 Tight.
Okay, anyways, you got it going. Yay. Okay.
Yay.
Next up, Coding Pro, and then we'll wrap up with Adam. Keep it to a couple minutes, folks, and we can get both of you in.
Okay. So here I have the lights off because I made this shirt with.
Whoa.
That's cool.
Nice.
With a NeoPixel strip. When I was putting this on, I broke it's actually conductive thread. So I broke a thread. So it's supposed to light up here and on my arm here, but it didn't do it this time.
Well, we didn't know that. It looks great on its own.
Okay, 1 second. I'm going to turn on the lights again because I have this other project, which I have shown before. The air quality monitor here. But this time it works. So right now, connecting to the Wi-Fi, and it's in green right now. So that's a range from 0 to 50 AQI, which is a measurement for the air quality index, basically. And you can see if I screen share to. Okay. So I got it from my data from this site here. It goes into the code I had here.
Yeah.
It gets the data and sends it to Adafruit.io here.
Nice.
Yeah, and I have the AQI level here, which goes straight to the board. And I'm currently working on a guide for it.
Yay! That'll be great. People will love that.
But the problem is, it's really complicated to get like a glitch project to stay up for a long time and then keep sending data. So I need to figure out a new way to get air quality data, which is probably going to include an RSS feed and IFTTT.
All right. Well, I have faith you can do it.
Yeah.
Good luck.
And sorry we all collectively ruined the planet and it's going to be red for the next 1,000 years, but it'll be green for a little bit longer. We can fix it.
All right. Couldn't if you need a sticker, email support Adafruit.
Okay.
All right. Adam, you got 2 minutes.
Hello.
Go.
So, long time no see. Fun stuff going on, but we'll talk more about that later. In the meantime, I've got the first project I ever came on Show and Tell with about 2 years ago, which was my first kind of scanning microscope. And it's not a scanning electron microscope, it's a scanning tunneling microscope. Ooh. And funnily enough, this little silver box here, when coupled with a massive amount of vibration dampening, actually has atomic resolution, which is hilarious because compared to the size of my other microscope, it's quite a bit smaller. So the way it works is it scans there's some images from it. It scans a really, really sharp tip across the surface of a sample and records monitors how many electrons jump from the sample to the tip through a process known as quantum tunneling. So literally leveraging quantum effects to generate an image. So I've got a tip here that's less than 0.1 microns wide that's etched in a bath of sodium hydroxide. using electrolysis. So you got the little ring, wire in it. It gets etched, it falls off, loaded into the holder. Holder goes into the microscope. That's kind of the microscope. That's the scan driver. And it scans it across the surface of some graphene, or highly oriented polygraphene. And we can actually get an incredible resolution from this thing. So these steps you see here are individual layers of atoms that this thing is stepping up. And eventually this microscope will be able to see individual atoms. I just haven't quite got it tuned well enough or tuned to the point where I can do that yet. It's incredibly finicky. If you bring the tip too close to the sample, so instead of actually scanning across, kind of like scanning just above the surface of the sample, if you just touch the sample a minute amount, the tip folds over like this, and you're done. And that was about 2 hours of work to get the tip in the microscope and to get it running, and it's just kind of all wasted after you do that. So it's pretty stressful getting one of these microscopes running. You just got to kind of sit there and turn it up very, very slowly. This is what it looks like when it's running. The entire scan assembly is suspended off these springs because the thing is incredibly sensitive to vibrations. I have it sitting on my SEM because my SEM's got a big vibration dampening plate. I'm not sharing screens, am I?
No, but we're looking at the really cool image behind you.
Looking at the one
Okay, okay.
It looks really cool. So we want to
run through
that.
everything. The entire time I meant to be sharing screens, so that I can actually like show the scan images or show what the tips look like.
Oh,
that's
I was looking at the background. I was like,
that's cool.
Yeah, that's kind of a tip in the background. Anyways, there's the 0.1 micron tip. There's the tip holder. There's the etching rig. There's the etching rig of sodium hydroxide electrolysis going on, so lots of fizzy bubbles. There's the scan head. There's the graphite. Let's see here. This is what it looks like when it's scanning. You got everything suspended underneath an an EMI shield. It's got to be on these big vibration dampeners because the thing's atomic resolution, and walking across the floor or a car driving by is enough to throw it off. So you got to have these massive springs and multiple stages of foam. And then this is the images we get. And so you can see these steps on the left-hand side here. Those are individual layers or atomically thick layers of graphene. And it's got the resolution to step between those. And eventually it'll have the resolution to see individual carbon atoms in the graphene. But as I said, the system is very sensitive. This is what happens when you go from kind of scanning the tip just above the surface of the sample, where you get quantum tunneling to the tip, to crashing the tip into the sample and bending it over. It's kind of funny. The quantum tunneling effect I'm using is the same thing. It's the same quantum tunneling effects that makes it hard to make processors small. Like that 7 nanometer limit they talk about, where electrons just start to jump around. That's the same thing I'm using here. I'm trying to get the electrons to jump from the sample to the tip, record how many jump at any one point, scan across a whole bunch of points, and generate an image. So it's a pretty cool little tiny microscope. It's a fun project. This is what it looks like before you crash a tip, and this is what it looks like after you crash a tip on the surface. Everything just kind of goes terrible. Anyways.
Thank you.
Really short summary of scanning tunneling.
Very short, very close. You are 7 nanometers away from 8 o'clock.
Yes.
All right. Well, thank you, everybody.
Adam looking at atoms.
Yes. Eventually.
Right. Well, thank you so much, everybody. Thank you, TG-Techie, Scott, and Pedro, Mike, Lucky Cat, Michael, Dave, and Adam will be on Show and Tell in just a minute. I'll cut it short. See you next week, 7:30 p.m. Eastern Time. Thank you, everybody, for the best half an hour of our week, every single week. Bye.